Okay, so for this fourth task, we're going to try to come up with an equation that'll allow us to input the number of teams that are competing in the tournament, and then our formula is going to output the seed of the big loser. So as it says here, to answer this question, we're going to use inductive reasoning, which is a technique where we look at answers to simple problems and then try to extend those answers to come up with equations for more difficult problems. To that end, we'll start with a ridiculously simple example here where we have two teams competing in a single elimination bracket. We wish to identify the big loser. Well, if the high seed wins as expected, then one would come through here, and that means that in this particular tournament, the 2 seed is the big loser. So what I'm going to do is I'm going to keep a table here that keeps track of various numbers of teams and what the seed of the big loser is in those situations. And then hopefully once I've tabulated some of this data, then I'll be able to come up with some sort of formula that allows me to input the number of teams, and I get as an output the seed of the big loser over here. So we know if there's 2 teams, the seed of the big loser is going to be number 2. Okay, what about the situation where there's 4 teams? Well, again, if we go ahead and advance the high seeds, then we have 1 coming through here, 2 coming through here, and 1 coming through here. The big loser is the team that's at the bottom of the chain of losing. So it wouldn't be 4 because 4 loses to 1, but then 1 goes on to win consecutive games. The team that's the big loser in this situation is number 3 because they lose to 2, who loses to 1. Go ahead and tabulate that. 4-team tournament, the seed of the big loser is 3. What do we have here? Well, let's go ahead and first advance all the high seeds through. Who's at the bottom of the chain of losing? Well, again, it's definitely not 8 because they lose to 1, but then 1 wins consecutive games all the way through to the championship. In this particular situation, I think that it's going to be number 6 who's the big loser. Let's see, 6 loses to 3, who loses to 2, who loses to 1. So it is 6 who's the big loser in this situation. We also know from task 2 that in the case of a 16-team tournament, the seed of the big loser will be number 11. And I actually had gone ahead and diagrammed out a 32-team tournament, which wasn't particularly easy. And I saw that in a situation like that, the seed of the big loser is actually going to end up being 22. Now, we could go on, but you can see that if we were actually trying to diagram out a 64-team tournament or a 128-team tournament, that it would be pretty tedious business to figure out what the seed of the big loser was going to be. So hopefully this is enough data in the table where we can identify some patterns and hopefully come up with an equation, again, where we can input the number of teams and then have our equation output the seed of the big loser so that you don't actually have to go through and diagram the more complicated situations. Our formula is going to need to make use of something called the ceiling function. The TI machines, at least this particular emulator, doesn't have a ceiling function built into it, so I had to write a quick program to show you how this works. Rather than explaining in detail, let me just show you what happens when I run this program. So it's allowing me to input any number that I want to. Let's say that I take 2.1 and I input that. Well, the output that I get from my ceiling function is the number 3. So it looks like what it did is it just took my number here and it rounded it up to the nearest whole number. Let's run the program again with some other numbers to see if you can understand how it works. Let's say I input 3.7. Well, when I hit enter, it takes my input and it rounds it up to the nearest whole number. What if I use as input, say, the number 6? Well, it just returns the number 6. There's no rounding up that needs to be done because the 6 is already at the nearest whole number. Okay, So one more time, just make sure that you understand that this is different than rounding to the nearest whole number. It's always rounding in a certain direction, the direction of up or towards the ceiling. So even if I have something that's very close to the number 2, my ceiling function should take that number and round it up to 3. And you can see that it does. So that's what a ceiling function does. And we're going to need to make use of that in our formula that's going to allow us to input the number of teams and then output the C to the big loser. The next step in developing our formula is going to be to recognize that to get the C to the big loser, we need to take a certain fraction of the total number of teams that we have. So the C to the big loser will be a certain fraction of the way down the list. In other words, if I take some fraction yet to be determined and multiply it by 2, then we're going to get close to the C to the big loser. In this case, the fraction would probably have to be 1, right? But let's say that I do this. I have some fraction times 4, and I get 3 as my output. Same thing, same thing, same thing. And you can quickly see that even though I'm using the same variable f, which suggests that it's going to be the same fraction each time, there's no way you're going to be able to find a single fraction that's going to be able to multiply by the number of teams and hit you directly on the C to the big loser. However, think back to the ceiling function. The ceiling function will take any decimal answers that we might get by multiplying by this fraction and then round the decimal answer so that we get a whole number, what we expect, for the C to the big loser. So right now what I want to do is try to figure out what this fraction is going to have to be. Okay, so make sure again you understand what I'm talking about. We're going to figure out some fraction. It's going to be something less than 1 so that when we multiply it by the number of teams we get very close to the C to the big loser. But again, there's no way that this is going to work exactly because inevitably when we multiply this fraction times the number of teams we're going to get some decimals. So that's where the ceiling function is going to come in, but we'll worry about that in just a second. Right now, let's try to see what that fraction might be. To get an idea of what the fraction might be, what we can do is we can take our data in the C to the big loser column, so here, and then we can divide that by the number of teams that we have in the tournament, and that'll give us some ideas. So for example, well, we don't even need to check the first one because we know that the fraction in that situation would be 1. But let's say that we look at the next pair of data values. We know that when the C to the big loser is 3, that happens when the number of teams is 4, and so that's giving us the fraction of 0.75, right? What about the next set of data values? When you use a C to a big loser of 6, that happens when the number of teams is 8, and that is also 0.75. So it looks like, you know, looking at the first couple of values here, that the C to the big loser can be found by going about 3/4 of the way down the list of your total number of teams. Unfortunately, that pattern changes starting with the next pair of values. If I input an 11 for the C to the big loser, divide that by the 16 teams, you can see in this situation that the decimal value of that is going to be about 0.6875. So that's definitely not 3/4 anymore. And I don't know, let's just look at this last pair here. If we have 22 as C to the big loser in the situation where there's 32 teams, then that fraction is going to end up being the same thing, about 0.6875. And so what is the fraction going to be? Well, there's really no easy way to explain how this works, but it turns out that the fraction that we're going to want to use is 2/3. Okay, so here's my finished formula. You can see that it's got these weird brackets that only have hooks on the top, and this is the notation that we use to show ceiling function. The way it works, as we already saw, is whatever number is inside the brackets here, we're going to take that number, and these brackets mean that the number is going to get rounded up to the nearest whole number, and that's going to be the output, which should hopefully give us the seed of the big loser. Anytime you come up with an equation, you should always see that it actually works. So if I go back to my calculator here, let's try it with some of the numbers that we have in the data table. Let's run the ceiling function again, and maybe we'll take a look at, say, this pair of values. We know that when we have 16 teams, there should be 11 coming out for the seed of the big loser. So applying the formula, if I take 2/3 and I multiply that by how many teams I have and get that decimal answer, whatever it is, and apply the ceiling function, then I should get as output the seed of the big loser, which hopefully comes out to be 11, and it does. Alright, this is looking good. Maybe we'll just check one other pair of values here. Let's try another one that you actually have diagrammed out yourself. Let's try this one here. We know that when the number of teams is 8, the seed of the big loser should be 6. So if we apply our formula, if we take 2/3 of the number of teams, apply the ceiling function to that, then we get 6. So I feel good about this formula. Your task is going to be to use Equation Editor and the proper notation and put this formula in your Google document where you are answering all the questions for this project. Hope this was helpful. Good luck.